So let us discuss how to calculate limit with limit laws. So in reality, when we calculate limits, we can use a lot of nice properties. So suppose we have two functions f and g that have limits. So when x approaches a, limit of f and limit of g do exist. So then limit of sum is the sum of limits. So this is basically limit of f plus limit of g. Similarly, limit of difference is difference in limits. So limit of f minus limit of g. So whenever you have sum of functions or difference in functions, you can take difference in limits or sum of limits to find the limit. For any constant c, so limit of constant multiple is constant multiple of the limit. So it's going to be c times limit f. So those first three properties are called linear property. When you take linear algebra or differential equation, eventually you will be using those three properties. Okay, even when you have product of two functions, you can find the limit just by taking product of limits. So it's going to be limit of f times limit of g, x approaches a. So far, we have quite intuitive and nice properties. So actually, everything else are quite intuitive and easy enough, but this quotient. So when you have quotient, well, we want this to be quotient in limits. Actually, that is true as long as the denominator is non-zero. So the limit of quotient is quotient of limits. Limit of f over limit of g. So let me emphasize this. Well, this is true only when your limit of g is non-zero. Well, so that means whenever this limit is non-zero, you can take quotient of limits to find the limit of quotient. We will discuss eventually further when your limit is 0 in the denominator. Okay, so the remaining properties are also quite straightforward. So the nth power of function f gives you nth power of the limit. So limit of f to the nth power. So quite intuitive. And a constant. Well, when you draw constant function, it's just a straight line. For any point, the value is constant c. So this limit is obviously just a c. And similarly, for this function x, when you draw graph of the function y equals x, for any value a, the function gives you a. So whenever your x approaches a, the function gives you the value a. So for this function x, we have limit a. Okay, and nth power, well, you can combine those two properties. So limit of x gives you a, and nth power gives you nth power of the limit. So combining those two properties, you can answer this limit. So basically, this is nth power of limit of x. So it's going to be just a to the nth. it looks like you are plugging in x equals a into the function. Well, plugging in works as long as your function is good enough. By a function, by a good enough function, I mean whenever you have non-zero denominator, you can plug in like this. So nth root is quite similar. So limit of nth root is nth root of the limit. So you take nth root of the limit of x as x approaches a. So this is nth root of a. And similarly, whenever you have a function, and then you take nth root, then the limit is just nth root of the limit. Okay, so from now we can use those nice properties, and let me emphasize once again, all properties are quite intuitive and straightforward, but this, whenever the denominator is 0, we will use some different approach to find the limit. Otherwise, it looks like you're plugging in some values.